SNS College of Technology, Department of Artificial Intelligence and Data Science, Principles of Operating Systems. In this session, we are going to discuss what is CPU scheduling, that is, its introduction, the two methods preemptive and non-preemptive scheduling, which are used by the operating system to manage the processes which are in the ready queue. CPU scheduling. A CPU scheduling in an operating system is a process of selecting which process should be used by the CPU at a given time when there are multiple processes in the ready queue. That is, it determines which process should get the CPU when and for how long. The main objective of this CPU scheduling is to maximize the CPU utilization and throughput while minimizing the waiting time, turnaround time, and response time, and also to ensure the fairness so that no process starves in the queue. CPU scheduling. Now, before we go with the various scheduling algorithms, we need to know what are the various types of CPU scheduling methods a CPU adopts. CPU scheduling can be either a primitive or a non-primitive, where a process runs until the particular process completes, or when the CPU can switch between the processes. A preemptive and a non-preemptive scheduling are the two methods used by an operating system to manage how the CPU is allocated to different processes. In a preemptive scheduling, the operating system has the authority to interrupt a running process and assign the CPU to another process. Usually, it is based on priority or a fixed time slice called a time quantum. This particular approach improves the responsiveness and also ensures that this particular CPU is being sharing, making it suitable for interactive and real-time systems where a quick response is very important. However, it involves frequent context switching, which increases the overhead and also makes the system more complex to manage. Common examples can be the round robin, shortest remaining time first, and the preemptive priority scheduling. Now, in this contrast, that is, the non preemptive scheduling here allows the process to keep the CPU until it either completes execution or voluntarily blocks for IO operations. The operating system does not forcibly remove the process from the CPU, and this method is simpler to implement and involves less overhead because context switching is not going to happen here frequently. However, this can lead to poor responsiveness as shorter or more urgent tasks may have to wait for longer tasks to finish, thereby causing some delays and what we call it as a convoy effect. Algorithms such as the first come, first serve, shortest job first, and non preemptive priority scheduling follows this particular approach. Overall, preemptive scheduling is preferred for interactive environments, while non preemptive scheduling is preferred where we need to have a batch system. Since the CPU can handle only one process at a time, the operating system maintains a ready queue and chooses a process based on a scheduling algorithm to ensure an efficient use of the system resources. Common scheduling algorithms include first come, first serve, shortest job first, priority scheduling, and round robin. This improves the overall system performance by reducing the idle CPU time and allowing the task to complete faster. In this session, we discussed what is CPU scheduling. We also discussed in detail the two methods preemptive and non-preemptive scheduling and how they schedule the processes in the ready queue to utilize the CPU for their completion. Next session, we will discuss the terminologies used while scheduling the ready queue processes. Thank you.